Okay, I believe I have 30 minutes, and we've got 300 slides to go through. So my name's Todd Truitt. I'm Director of Systems Engineering. Illumio does one thing, micro-segmentation. But this won't be a product pitch. This will be something that I'm going to go through the things we've learned after doing this with companies for about 5 years. And our experience has been from anything as small as a venture capital shop that may have 16 servers to as large as JPMC or Citibank that may have over 100,000 servers. So we've got a breadth of experience in this market, and a couple of these considerations we'll go through. I promise you, it's things we've learned the hard way, as have our customers. So today's discussion is why use micro-segmentation at all? Does everyone know what micro-segmentation is? Does anyone? Okay, a few, thanks. Is anyone doing it today? No? Just a handful, a little bit. Yep, okay. So we'll talk about why what micro-segmentation is, why we'll do it, and then what are the considerations when you're rolling it out. And then finally, kind of the 5 easy steps we've developed that we tell customers on how to successfully micro-segment their environment. So why use micro-segmentation? Does anyone recognize this attack? It happened in 2013. This is the target attack. The attackers came in through Fazio Mechanical. It's a third party. They're an HVAC vendor. They had a connection through the vendor portal. The attackers basically compromised the weakest workload within this HVAC vendor's, Fazio Mechanical's data center. They traversed through the vendor portal to Target's data centers, and from there infiltrated the PCI environment of all their stores. Now this attack took place, it was about a 5-month attack overall. Believe it or not, their internal systems did actually alert on some of the tripwires they had set, but the company gotten so many alerts, they ignored them. Now, they put on multiple versions of malware and eventually exfiltrated all of that credit card and debit card information. One of the largest breaches at the time. Now, you'd think 5 years ago that we would have solved this problem. But really, there's been a number of attacks. One of the most recent was the Swift attack in a Taiwanese bank. Used the exact same methodology. An average dwell time of 142 days. Now, all these attacks are very similar. They find the weakest workload, they infiltrate, they traverse east to west through the data center, even through partners' data centers. Then they find the high-value assets. Could be patient data, could be credit card data, could be financial data. Then they insert malware to exfiltrate that data. These are how these attacks are happening. And this is why micro-segmentation is becoming such a hot button right now. And there's only 3 reasons to do it. The first piece is to control which application groups are talking to other application groups. If they're going to be talking, narrow down the span, the scope that those 2 groups are talking on. If they shouldn't be talking, stop communication between them. Just controlling access between application groups. The next piece is containing the blast radius of an attack. So if something is compromised, the exposure, the risk is mitigated. Ideally within that one application group, and even better, just that one workload within that application group or zone. And then finally, to turn each of those application groups, each of those zones, into tripwires, so that as an attacker tries to move laterally across a data center or across the cloud environment, they actually set off a bunch of alarms, so many alarms that they can't be ignored. So that's why people are moving to the micro-segmentation. This isn't a new concept. Companies have been doing segmentation for a long time, but we've been trying to do it with router ACLs, maybe ACLs and switches, with internal firewalls. The problem is that's become completely complex right now. Environments are dynamic. vMotion has allowed workloads to move from one rack to another. IP addresses are randomly changing. DevOps are spinning up new workloads and tearing them down. They're ephemeral, particularly when they're a QA environment or a test environment. So it becomes very difficult to use things like firewalls that are very static by nature, that typically have IP addresses and ports tied to them, to secure internal movement. Additionally, when you're configuring a firewall, best case, if you own the network, if you're in control of it, it's about a 4-hour change ticket on average. But a lot of our organizations out here, they're outsourced networks, so it's more likely it's going to be 2 weeks before you can get a change order in. And on top of that, because of the complexity of networks, because we don't have great visibility in the true traffic flows, there's an 87%, almost 90% of that, of the internal errors are configuration errors. So now you have to submit another ticket to get it right. I was just meeting with a bank in Singapore. They'd done an internal firewall change to lock down a payment system. They actually locked out their users, locked out the payment systems for 4 hours. Cost them millions of dollars. Why? They got an IP address wrong. The person just fat-fingered IP address, and it's happened to all of us. So this is why, in today's world, segmenting the old way is just not scaling. And this is an example. This is less than 100 workloads. This is from one of my customers. We've sanitized the data, obviously, but that's 100 workloads. And that really shows how complex data centers are right now. So they're dynamic by nature, they're distributed, they're interdependent. These apps all talk together, and on top of that, you've got core services talking to them, and they're reporting to other core services. And they're increasingly hybrid. They're crossing from an on-prem data center to bursting to cloud apps, or their development groups in the clouds. So really, this is what environments look like today in our largest customers. There's a legacy environment protected by ACLs and routers, lots of bare metal, big, heavy databases, legacy applications running on AIX or Solaris. And then you may have your new on-prem private cloud, VMware, spinning up and down. This could be an OpenStack environment. This is where everyone's really excited about. And then you go into the cloud. We're seeing a huge cloud-first movement in Australia right now. And increasingly, it's become a dual cloud strategy with both Azure, AWS, and actually even some Google Compute out there. And then finally, every developer I talked to in the last 6 months has been talking about containers. Now, the funny thing is, as I talk to each of these groups, they're silos. They really believe that that's how they operate. And they've done a great job locking down and using the native security controls within each of those to control them as much as they can. The complexity comes is these applications actually, most of the time, they have to share communications. Not just with core services, with the core data center. A lot of times the databases live here. And even the container environments, that they're development environments today, so they think, oh no, we can live on an island, we can use Calico, we'll use our internal tools. As soon as those things go in production, they're noticing the traffic patterns are going back to the private cloud or back to that legacy data center. And on top of that, we've all spent a lot of money on the tooling environment. And the tooling environment doesn't just operate independently either. Artifactory, hardened images, they're going to be tied into your DevOps tools and your DevSecOps tools. You'll have vulnerability information that you want to pull and glean from so you know where to lay down your micro-segmentation. You're going to be reporting to a variety of Splunk or QRadar. So all of these are tied in, even the CMDBs, because you need good label data to know what these systems really are. So in truth, this is today's ecosystem in a modern enterprise. And now this is why micro-segmentation becomes very daunting to customers. So as you're looking at, with that in mind, here's some of the considerations we're telling customers to really take a look at. Whatever solution you pick, make sure it's multi-platform, supports multiple environments. Because even if you're not that way today, odds are that's where you're going. I can't stress this enough. Map all application communication. That's why throwing in firewalls or ACLs is very difficult and frankly dangerous, because you never know what those communications actually are. And it's not just a snapshot, it's looking at over a month or a quarter. And in a quarter batch job, we've actually broken that before laying it out, because we'd rolled it out, tested it for a while, modeled it over a month, put it in enforcement. What do you know? At the end of a fiscal quarter, this batch job that no one knew about, that had been going on for years, came up and we broke it. We broke the business. So that's something we've learned the hard way about this stuff. So really understand that mapping of all application communication. Intuitive rule writing is becoming increasingly important because the IP addresses aren't that valuable as information anymore because they move around. The model and test before enforcement is just, I can't stress that enough. These are such complex environments that the modeling and testing of it is really critical. And a fully programmable API, GUI is great, it demos well, but if we're not really plugged in with an API, it's not going to scale. And the reason is, if you're going to roll out micro-segmentation, it's got to be tied into the DevOps. As people are spinning up workloads, it's not, micro-segmentation can't be lined up loaded on top after the fact, because then security teams become the bottleneck. It's got to be integrated as they roll out the applications. Also, to make this effective, you want to pull in from other sources of truth. You want to pull in the CMDB data so you actually know what these systems are. So when you find an alert, it's not some crazy host name that you have no idea what that is, you actually see, oh, that's my front end to a payment system. That's pretty important. I should dive in and look at that. And you want to be able to map other ecosystem partners like vulnerability maps, virus scanning on top of that, so you can see what's truly vulnerable. For scaling, centralized policy creation with distributed enforcement, get as close to the workloads as you can. If you can only get to a firewall, that's great. If you can go closer and go to the hypervisor, that's even better. If you can get even closer all the way to the workload itself, that's the ideal, as long as you can centralize the policy management of that. And then tunable granularity. Micro-segmentation is great, but it's not for everything. Macro-segmentation, coarse-grained segmentation, should be good enough for a lot of environments. Maybe separating just dev and test from prod. That's actually still really useful to the business. And that's kind of coarse-grained, so don't think too deep here. That's a pretty good starting point. Any questions on that before I move on? No? So the 5 steps we've learned, and we've kind of learned this the hard way. Get the right tools up front, and then integrate those tools. Because the better they're integrated, the more they work together, the better your knowledge set will be, and on top of it, the better value you're getting for all those purchases. So really, if you can't integrate these tools, if they're just silos, take a step back. It may not be worth investing in them, because you'll probably only get 60% usefulness out of any one of these tools. But combined, all of a sudden you can get 120% if you do it the right way. Decide what to segment first. And I'm going to go into this in some depth, but you can't segment everything in the enterprise. That's a project that's like doomed for failure before you take your first step. Start small, be successful, learn how it changes the operations map, and then go to the next one. Map your application environment and do this over a period of time, because the last thing we want to do as security professionals is roll out something and break the business. It gives us a black eye, we lose faith, and it stalls before we can do the next project. So really take your time and map out all that internal communication. Test and then enforce. Yes, question? Yeah.
And if you've got 100 apps, it sort of exponentially gets more and more difficult. So I'm sure there's tools out there that can probably help.
It's a great question. So the question is, he's like saying, Todd, that's great. I'd love to be able to map all that stuff out, but show me how to do it. Well, there's a number of tools, and some of them are better than others. Like we've had NetFlow for a long time, but the problem is NetFlow is just tied to IP addresses, so then we do reverse DNS lookups. We create these big spreadsheets. Those spreadsheets become massive, and actually getting any redeemable data out of that is, I've been doing this for a long time. I've yet to see really good data coming out of NetFlow. So the next thing is, okay, are there applications out there that can do it? And there are. And if you want to come find me later, I can show you exactly how to do it. What it suggests is there's different levels. You can start at the network level, and it sees a lot. But the problem with network-based tools, and I say this as an ex-Cisco guy, is even NetFlow is lossy. So it takes snapshots, but it's not the complete flows. And on top of it, it doesn't show you all the way to the endpoint. So try to go all the way to the endpoint if you can, because that tells you a couple things. It tells you exactly which host is initiating those connections, but more importantly, if you can, find out which processes are initiating and receiving those connections as well. And there is software out there that does that, and I can talk to you about that afterwards. The test and then enforce, once again, this depends on which tools you're using. If you're using a network-based enforcement, this can be more daunting. Like you can't really test ACLs on a router. You can do a better job with some firewalls. I think NSX, I'm not sure what testing capability you have, but it's got some. There are other tools where you can actually model some of this stuff and then put it in test mode over a period of time so that you can see the flows. You can catch those batch jobs or cron jobs or backup jobs. And that way, over a month, a quarter, JPMC actually did it for 367 days. So the entire fiscal year plus 2 days of their fiscal year close up before they'd move into enforcement on just a handful of applications. So different customers do this differently based off the level of risk that they're willing to tolerate. And then finally, decide what to segment next. So as I said, and this goes back to number 2, You can't do everything at once. It's just not going to work. There'll be 2 or 3 failures. There'll be a regime change. Someone's going to lose their job before the project ever gets off to phase 2. Instead, pick an application, work with the application developers, make it successful, learn the lessons on how it changes the operations of your own teams and other teams, then go on to App 2, App 3, and App 4. So, step 1, what do I mean by get the right tools? So, back to your question, get really good application dependency software. Something that really shows you graphically, not just can build a tabular view, but also a map. So you can bundle your applications together in groups, and you can look at not just what's within the group, but what's coming in and out of that group. And I'll go into that in more detail. As part of this isn't useful unless you have those APIs to pull from your sources of truth. And this could be as great as maybe a ServiceNow database where you're pulling all of that CMDB data down and incorporating that into your map. Or it could be as simple as an Excel spreadsheet that shows IP subnets and which locations they are, which data centers or which zones, production versus dev. Sucking that in and applying those labels is actually really helpful to know where you're going to microsegment. Because maybe you don't need to microsegment something in application 1 that's a development because it's really low risk. But you probably do need to microsegment application 1 in production because it's your customer-facing application that's making a lot of money. So those labels become really important. And then take your vulnerability mapping, your Rapid7, your Qualys, your Nessus, and layer it on top. And the reason I mention this is because those on their own are halfway useful. And let me elaborate. If I'm an application and I'm at low risk, because that's what the Qualys has shown me, that may not actually be true. Because if my application is linked to 2 other applications that are both high risk, because I've got connections to them, I actually inherit their risk. So now you have 3 application groups all at high risk because of that. So being able to map that vulnerability data on top of that actually becomes pretty important because it's going to help you prioritize where you're going to throw in your microsegmentation areas. Policy management. This is problematic. I worked with a very large credit card company in the US before I came over, and they were doing this on their own. They'd created their own tools, and they were instrumenting the host-based firewalls at large scale using Puppet scripts. But they had no change management control. It wasn't part of their scripting database, so they couldn't keep track of the policies. So they had a great way to distribute those policies, no way to maintain a policy management database. So when someone made the mistake, they couldn't do a change back. They couldn't roll back. So it became actually quite cumbersome. And they ended up having some problems with some of their applications. So a good policy management platform is critical. And then the enforcement piece, which I've already hit on, says just make sure it's easy for testing, validation. And then anything that is implemented, don't implement it just thinking you're going to do this one small application. Think about how you're going to do it at scale, how it's going to integrate with the SIMs and the reporting pieces, how it's going to integrate with DevOps. And all of us are going to have to face this DevOps thing because it's happening very quickly. And we as security professionals don't want to be that bottleneck. It's the go, slow, or no. It used to be that go is the application team, slow was a network team, and no was a security team. Well, the network team's getting faster and faster. We're going to have to increase our speed too. It's going to be go, go, go. And by integration with DevOps, that's how we'll do it. And by that I mean, as they're spinning up scripts like a Puppet or a Chef script to go spin up a workload in AWS or in their on-prem environment, we need to be part of that Chef script that automates the deployment or the updating of our microsegmentation policies. So it's got to be completely integrated. And that's where that API comes in and is so important. Decide what to segment first. This sounds really easy. It's actually one of the hardest things in working with customers. Because the security team may want to do one thing, the apps team may want to do the other, but it really comes down to what does a business need? And these decisions are really driven by a number of factors. First and foremost is the level of risk, the exposure. What's the value of the data that you're protecting? The next one is, frankly, we may not be in control of what we have to microsegment. Probably someone's going to tell us, a compliance officer, an auditor. In the banking environment, it's SWIFT. The US banks won't do business, won't transfer money if you're not SWIFT compliant anymore. So that's cascaded down, and that came from the Fed. That's cascaded over to Europe, now it's coming over to Asia, where everyone has to be compliant for protecting or segmenting their payment systems from the rest of the world. The next one that's going to come down from the US as well is patient data. Patient data is critical, and we've got the HIPAA compliance going on in the US. That's going to roll everywhere else. In Europe, they're initiating personal data, private integrity with GDPR. That's going to hit all of us as well. So that means anyone who's got any private citizen data, any employee data, a government agency that's got a lot of public data, that's going to be critical to lock that down. So our compliance auditors are going to tell us how we have to lock that down. Next one is inherited exposure, which also comes to value as a pivot point. Can you lock down an application to make sure that no one can pivot off that application to get to something even more important? For hospital I was working with in the States, it was actually, they had to lock down their image repository because that was directly tied to their patient data. And that patient data was so critical to them. So they ended up having to lock down chains of applications to make sure they protected it. What's the harm to the business if there is an outage? Now that becomes a key factor as well. And then finally, and I say this kind of jokingly, but it's not, I've got a lot of customers here that have legacy systems that just over time, these things have sprawled all over their enterprise. And they can't lock these down with any other tools than find some way to maybe control those with their host-based firewalls because they're distributed so far away. They can't pick them up and move them around. Mapping your application environment. And this is really important. And I showed this picture for a reason because apps have intentionally sprawled out. They're distributed across multiple environments for HA, for responsiveness. Now, segmenting that, it's very difficult because now you have to touch each of those locations. So finding software that can take that distributed application and bring it together in a single application group so you can look at it as developers look at their apps becomes increasingly important in today's environments, especially in hybrid environments where the front end might be in the cloud and your back end data and processing may be back on-prem because those are the crown jewels. So being able to look at an application holistically is really important to really not break it. What I've found is when you're protecting, and like I say, start with a single application and go from there. The first piece is start with our brethren in IT. Identify the core services that touches every workload out there and create policies for that are enterprise-wide. Pretty soon you've got a standard. The next piece is, once you find that single application, the first one you're going to go after, validate the interactions within that bubble, within the application group. This could be as easy as, I don't know what these are. I'm going to say allow everything between these workloads, or you could break it down by tiers. And what we found is that if we engage the application teams, they actually get excited about this because a lot of them don't really know how their applications have grown up and all the things that we talk to. So work with the application teams on this one because it accelerates the path to success. Then the third step, and really this is the part that creates micro-segmentation, is then and only then do you focus on all the connections going in and out to other groups. And this is the tricky part. So you've already identified your core services, which helps a lot, but this is where you'll find, oh, there's a link to Artifactory I didn't even know about, so the developers can upgrade this application on the evenings. Yeah, we've broken that before. So that's the kind of thing that you look at over time to make sure you get all those inter-application connections. And that's really, all this is, that step will get you to a ring fence, putting a safe fence around an application group. The test enforcement, just model, and do it over a period of time. This isn't a week-long thing. This is a month or a quarter at least to really model it so you catch those backup jobs, those cron jobs, those updates, those batch jobs. Because the last thing you want to do is break an end of quarter. Provide visual feedback, and ideally, the micro-segmentation solution you're looking at, or combination solutions, which is most likely, are all adaptive, and because it's a very dynamic environment. We found enterprise networks change quite a bit quarter to quarter. The number of workloads that are spun up, the new application groups, they're not sunsetted as quickly as we thought they'd be. They kind of get spun up and stay there. and then decide what to segment next. So in this one, I really come back to not everything needs micro-segmentation, or even, go with coarse grain segmentation. Macro segmentation is perfectly good for a lot of areas. So real world examples on where I'm seeing people turn on micro-segmentation. The first was in financials, actually, and it was just protecting, the first two. Environmental separation. So Morgan Stanley, a couple years ago, they had a developer initiate a phantom trade as part of his development testing in a QA environment. It actually initiated on their production environment and then decay. Good news, they made a couple $1,000s off the stock transfer. They were subsequently fined tens of millions of dollars for a trade that shouldn't have happened, a phantom trade. So they had a very monetary, to the business, this was critically important to make sure that UAT and dev could never talk to prod. That was their first rule. Very much macro segmentation. The next one we're seeing is really the payment systems. Locking down critical applications or public, private data, locking those down, surrounding those. A lot of people don't care about anything else, but they have to lock down those because auditors and compliance officers are making them lock it down. This is a brand new one that's becoming increasingly interesting, and that's a vulnerability-based segmentation. Because of the inherited risk with connected systems, just because you're low or even medium on the risk profile, if you've got a wide open connection to an application group that's high risk, you've inherited their risk. So this has segmentation has turned into a compensating control for that kind of inherited risk, because you're not going to be able to update or patch all those systems, very rapidly. Tier segmentation, just locking down, making it harder for anyone to traverse laterally east to west. So this way, web can only talk to app. Web can't talk all the way down to DB. It sounds simple, but that's a really useful piece of segmentation that provides a lot of value and a tripwire for an attacker that's trying to get in. And then protecting things like Active Directory. We're seeing attacks, and this started in the States a few years ago, and then it happened just in Europe, like I want to say 18 months ago, where people started taking down, they'd hold people hostage, and then they'd take down their core services. If you don't have Active Directory, if you don't have DNS, guess what? There's not a lot of stuff that's going on in your network. So taking down core services and protecting them has become increasingly important. So just some closing thoughts. Start with visibility. I can't tell you how many projects stalled because they didn't know about all the connections, and they took it down. So that visibility mapping is really critical. Test the policies before enforcing. You can see a theme. Build partnerships. This is one of the most effective things we've learned is really these two. Build partnerships between security, the infrastructure team. By that I mean not just the network team, but the server team, the VM team. The infrastructure team is key. Get them on board because you'll be working with them. And then the applications teams, because you don't segment servers, you segment applications. So you have to have the apps team involved. And if I could add anyone else on here, it'd be the DevOps team, because we have to integrate with their tool sets. We have to add components into their Chef, their Puppet, their SCCM, whatever tools they're using to automate these workloads spinning up and down. Segment in phases, don't try to do it all at once. And then this one, we learned this one really at Citigroup. We had a champion, senior vice president, who really wanted to lock his network down. And having a champion who would go out and sell why to do micro-segmentation to each of the business owners became really key for us to get engage with their apps teams and move quickly, app by app by app. That's, like I said, number 3 and number 5 are just critical to successful implementations. So if you have any questions, come visit us at the Illumio booth. I'll say this isn't something that a single vendor can solve. You have to work together. It's really an ecosystem solution because it's complex. But we really can start preventing this lateral attack that happens more and more here. So thank you for your time.
Yeah, let's thank Todd, everybody.